In this video we're going to look at a couple of different methods for graphing lines. And in the first example here we're going to use a plotting method where we're just going to come up with values of x and substitute in, get their point and plot them and join the dots together. So if we're going to take the value of x equals 5, now we shouldn't get too worried about this. These are just values that I've basically plucked up out of thin air. I've chosen 0 because of its simplicity. I've chosen 5 and -5 so that there's a range of values. These 3 points need to line up. You only really need 2 points to draw a line, but the third one will just make it that you're minimizing your chances of making a mistake. So if we take x equals 5, 2 times 5 take away 2 is equal to 10 take 2, which is 8. So that will be an 8 there. So the point will be 5, 8. Okay, if we think about x equaling 0, we'll get 2 times 0, take away 2. So 2 times 0 is 0, subtract 2 is -2. So this is -2. So another point for the line is 0, -2. And if we substitute in -5, it will be 2 times -5 subtract 2, which is -10 take away 2, which is -12. So this gives us a point -5, -12. Now if we plot each of those points, 5, 8, and for me on this computer screen it takes a fair bit to do this. 0, -2, that one's good, and -5, -12 will be about here. And then if we get a ruler, line up, hopefully those 3 points should form a line. Okay, and that's our line. If you're doing more than one line, you usually write the equation that's relevant. So y equals 2x take away 2. And just one thing that I didn't point out before, but remember 2x means 2 times x, so that's why before I kept writing 2 times. Okay, with this second one we're going to use the second method that's discussed in the module, which is the intercept method. Now if you want to find the y-intercept, and the y-intercept is where the line will cut the y-axis, so it'll be somewhere up or down here. So the y-intercept occurs when x equals 0. And what I mean by that is all up and down this y-axis here, the x coordinate is 0. So basically if x is equal to 0, we just substitute in x equals 0. Now this is the line that we're doing, so it becomes 3 times 0 take away y is equal to 6. So 3 times 0 is 0, so we can basically put 0 down or just forget about it. Minus y is equal to 6. And the usual thing to get rid of the minus sign is we times both sides or multiply both sides by -1. So -1 times -y becomes y, and -1 times 6 becomes -6. So that makes the coordinate, or I should say the point, 0, -6. So that is exactly there. Now the x-intercept, okay, that's where the line will cut the x-axis, occurs when y equals 0. We know that everywhere along the x-axis here, y is equal to 0. So we substitute in y equals 0. So 3x take away 0 is equal to 6. So that means just 3x is equal to 6. Dividing both sides by 3, x is equal to 6 divided by 3, which is 2. So that makes that coordinate 2, 0. 2, 0 is there. So we've got our 2 points, one being the x-axis and one being the y, and we can draw a line through those 2 points. Now, there's always pluses and minuses. The negative with this method, the intercept method, is that you're only using 2 points. So if you make a mistake, there's no way of picking it up. Where with the first one that we did before, with the 3 points, if those points don't line up, you've made a mistake and you can pick it up. But with the intercept method, you can't do that. Sometimes with the intercept method too, the numbers can be quite awkward. So, but it is a good method though, from the point of view that it makes you very aware of where the line cuts the x-axis and the y-axis. And if you're talking about a graph for a real situation, that can have some meaning. And if you think of one of the examples that we did before about the backpacker having $2,000 for a holiday, the y-intercept was the amount of money that she originally started with, and the x-intercept was when she basically ran out of money. Okay, this example, I'm going to do this by plotting points, and we can do this off the top of our head, I think. So if we take, this is a Q here, so if we take Q stands for quantity, by the way. This is a business example. So if the quantity is 0, then R, which stands for revenue, is also 0, because 50 times 0 is equal to 0. So that means that the graph goes through the origin, which is 0, 0. Then take another point. Look, our graph goes up to about 100. The more we can spread out our points, the better. So if Q is equal to 100, then the amount of revenue will be 50 times 100, which is 5,000. Okay, so you can see that I've manipulated this graph for the numbers to be pretty nice. You may not have that in some examples that you're going to do. And if we wanted to choose something in between, like 50 times 50 is 2,500, that's going to be about here somewhere. So getting your ruler, putting it on those points, draw your line. Now, we don't extend the line on because there would be some suggestion there that would be going into other quadrants where we're talking about a negative quantity or a negative revenue, and in a business sense that doesn't kind of make sense, so we just leave that like that. Okay, and one more. These are just special situations. We've got we need to graph the lines y equals -2 and x equals 4. Now, if you look at all the other lines that we've done, we've had a variable on both sides, okay, or 2 variables involved. But with this particular one, we've only got y equals -2, a number. There's no other variable. So, and x equals 4. There's only one variable. So these are special. They sort of are different. They're special. So one way that helps me an awful lot with these is that if it's got y equals -2, that's trying to tell me that the y coordinate is always -2. So in other words, we could have points like 0, -2. We could have 1, -2. We could have -5, -2. So the y coordinate is always minus or -2. And if you were to plot those points, they would all plot along a line that went like this. Y equals -2. All right, everywhere along this line, the y coordinate is -2, and because there's no mention of x, let's, for the sake of making life easy, just say we really don't care about what x is. Okay, so when we go to the next one, x equals 4, that's telling us that the x coordinate is always 4. So it could be like 4, 0, 4, 16, 4, negative 4, 4, negative 100, whatever. All we know is that the x coordinate is always 4. So that must give us a line that fits this description here. Because if we go up and down this line, the x coordinate is always 4. Okay, I hope that helps. That's how I remember these. I remember them as special cases. There's only a single variable, so it's telling me that that coordinate is what's stated.